Physics lesson 10.6, boundaries and standing waves. Jump roping. Oh, silly Tyrannosaurus Rex. Alright, so first let's talk about a boundary. So up until this point we've had all of our waves moving in the same medium. But now we're going to have them switching between boundaries. And when this happens, what we can get is something called a reflection, which means that some of that wave's energy bounces back into the original medium, or we can have a refraction. And that's when some of that wave's energy continues through the new medium. Big thing here is that the speed will change now. Before the speed wasn't changing, now the speed is changing because we're changing mediums, and of course the speed of a wave is determined by the substance or material in which it's going through, and we call that a medium. Medium. Okay, but either way, the frequency is unchanged. So if it's one wave per 5 seconds, same idea. Alright, standing waves. So this is when a wave travels through a medium and these waves cause interference, and this interference makes the wave look like it's standing in place. So if you look back at our jump roping Tyrannosaurus Rex, if you can picture this going over and over, it looks like it'll have a crest and a trough on the same rope, and that is a standing wave. It's an optical illusion. It's not real. There is only half a wave there, and when we talk about that, we call that harmonics. What determines these harmonics is whether or not the ends are fixed or not fixed, in which we call loose. If we're dealing with a fixed wave, so fixed on both ends, what we're going to have is a standing wave that looks like this. So we'll have an antinode and two nodes. This is the first harmonic. So first harmonic, one antinode, second harmonic, technically it's two antinodes, or I can just count them right there. Third harmonic, right there. And the wavelength is determined by 2 times the length of the string. So in order to fit a whole wave in the first harmonic, it's got to go there and back. On the second harmonic, we can fit the entire wave on there, right? Crest and trough. So it's just 2 over 2, which is 1. So the length of the string. And on the third harmonic, we end up with 2/3 because you can fit 1 1/2, right? Third harmonic. Fun. Formula-wise, this is what we're looking at. Wavelength is N. So N is our harmonic, first harmonic, second harmonic, third harmonic. And whatever harmonic you're looking for, you're just going to replace that N with the number. So if you were looking for the first harmonic, it would be, I don't know why I'm writing on a weird angle, 2 over 1 times L. If you were looking for the second harmonic, 2 over 2 times L. If you were looking for the 15th harmonic, it would be 2 over 15 times L. Alright, frequency, same idea. N represents what harmonic you're on. V is the speed or velocity of the wave. And then L is the length of the medium or string or whatever it's going through. If you are dealing with a medium that has 2 open ends, so this happens in the column of air, like what's that Phantom of the Opera thing, the organ, when you have the pipes. When that happens, it's going to be really difficult because it's exactly the same as 2 fixed ends. So same formula, don't need to do anything at all. What makes it tricky is when you have one end open and one end closed. This can occur in a string or a column of air if you tap one end, and what we end up with is having a node to start with, right, at one end, so it always is going to end in a node. So first harmonic, can't fit another one, so that's the third harmonic and fifth harmonic. Notice that there is not a second or fourth harmonic because they only do odds. So big change here is instead of a 2 on top, we have a 4. we've gone to the number 4. N, again, still the number, still the harmonic. So first, third, or fifth. The big thing here is it's the odd numbers. All right. I will see you on a later date. Have a good evening, afternoon, or morning. I don't know what time you're watching this. Except for you. What are you doing? There's these numbers. Okay, goodbye.